Hey guys, I want to review some stuff we have done about percents so far. We're about to get into some really hard percent stuff starting in our next lesson, and so I just want to do a little review and talk about some things we've seen so far for percent. So open up to your next free page, make this the title, pause, and when you're all done, unpause and give me your total concentration on the I do, and get ready to write on the we do. So we've looked at two types of problems at different kinds of types this year. Percent problems and percent increase or decrease problems. Percent problems, are things where you see, like 2 kids out of 5 have a hat. What percent is that? Or 20% of my 30 students wore blue. How many is that? Right? They're just questions where you're given you either find the percent or you find the part. This one's, you're asking for the part. Or you could be asked to find the whole too, but it's just a basic problem where it's, you have a part out of 100 equals a part out of a whole, and you find one of the things. Basic problem. Then later in the year, we talked about percent increase or decrease, where it was sort of like, a $20 shirt is 10% off. How much is it? So we didn't find a percent so much as we increased or decreased a number by a percent. Could have been where we find the percent too. Here you find the part. Sometimes it was also like, it's usually $30. Now it's $15. $15, not percent. What's the percent off? Those were increase or decrease problems. So we had kind of percent problems, and we had percent increase or decrease problems. All right, so let's do a couple. So let's take this situation. 13 girls and 17 boys are on the Science Olympiad team this year. Two kinds of questions. So this is going to be a percent problem. What percent of the team is boys and what percent is girls? So that's one of the basic, beginning of the year, 6th grade percent problems, right? So remember, a percent is a ratio. It's a part to whole ratio. So with the percent, my part to whole here is, I don't know, it's out of 100. So I want to know what percent out of 100 is part to whole, is my part to whole of kids, part to whole. So if I want to find what percent is boys, the part that's boys is 7, and the whole is everybody, which is 20 kids on the team. And now I can use that part to whole ratio to find the part. So that is multiply by 5. So that is multiplied by 5, and 35% is boys. I could do the same thing again for girls with 13, or I could just kind of say, well, I know these have to add up to 100, so if 35% are boys, 65% are girls. That's just a basic find the percent kind of problem. The percent increase or decrease problems are a little more complicated. So here, what percent more girls are on the team than boys? So basically, I'm saying I have 7 boys plus some percent that I don't know equals my 13 girls. So there's 7 boys. What percent more of 7 is 13? So this is a more complicated percent problem to solve. I'm going to need my calculator, I think. So here's how I'm thinking about this, right? 7 boys plus some percent makes 13. So I know that I'm adding, there are 6 more girls. That's not 6% more. There are 6 more girls on the team than boys. And I want to know what percent that is out of 7. What did I increase 7 by to get to 13? So I need to know what percent of 7 is 6. That's really what I'm trying to figure out. Boys plus some percent makes 13. So remember again, I've got a part to whole ratio, so I've got what percent out of 100. And here I'm comparing 7 and 6. The 13 is not really involved in the problem here. So I want to know what part of 7 is 6. It's a big part. It's actually almost all of it. Right? So my ratio is going to be part to whole, 6 out of 7. So now, I was right, I do need my calculator. So 7 times what is 100? I don't know. It is 14 and something. So I'm going to multiply that same 14 and something on the top. So I'm actually just going to keep it on my calculator and multiply the 6 by it. And it should be a big number, right? Yeah, 85% about increase. 85 and 7/10 if I round it. So there are 85% more girls on the team. 85 and 7/10, let's say, more girls on the team than boys, right? And that makes sense. 100% increase would be 7, and 100% would be 7. So if there was 14 girls, that would be 100% increase. So if we only have 7 and we add 6 girls, that's adding 85%. So that's the difference between a percent increase problem and just a regular old percent problem. These are fairly simple. These are fairly complicated. You have to do a lot of thinking and strategizing when you do these kind of problems. All right, open your notebook and let's do one together. All right, so let's talk about buying some gas. So Renata spent $23.25 on gas for her car. This was 40% of the money she had with her. How much money did she start with? So this is a regular percent problem. So as you're writing this down, please differentiate between a percent problem and a percent increase. All right, so part to whole. And part to whole. And often with percent problems, so we're going to set up 2 ratios here. We're going to do our percent one, percent out of 100, and our part and our whole. And the first thing to do is to figure out what do you need to know. Sometimes you need to figure out the percent. Sometimes you need to figure out the part, and sometimes you need to figure out the whole. The questions can ask you for any of those 3. And you just got to kind of figure out which one you need to know. In this case, I know the percent, so 40 out of 100. And this $23.25 was part of her money. It obviously wasn't all of her money. It was only 40% of what she had. So in this case, I know the part, and I don't know the whole. That was her amount of money. We'll give it a variable right there. So it's a part to whole question where I'm asked to find the whole, not the part of the person. Any of the 3 could be asked. All right. So let's see. So to get, I want to know how to get from here to here. Right? So to get from here to here, it's going to be smaller. 23.25 divided by 40. I'm going to multiply by a decimal, right? Times 58.125 times 58.125. Should be small, right? Because I'm multiplying, I have less over here than over there. So I'm multiplying by a decimal. 58.125 times 100. So it looks like she started with $58.12 or 13 cents. Let's say 12. So she had 58.12 or 58 13, depending on how you want to round it. So just found that. So that's a basic percent problem. Those ones are not usually too bad. It's just a simple ratio. This is going to be a percent increase decrease problem. They are tougher. They take more setup, and you have to really understand what you're doing before you solve them. So the gas she bought was 10% off of its usual price because of reward points for not ahead earned. What was the original price? So what I've got is some original price that we don't know. Call it P for price, maybe. Take away 10% is the price she paid, $23.25. And so we've got to figure out what the original price was. So one of the strategies we learned before was to think of it this way. If she saved 10%, that's the same as she paid 90% of the price, the original price. And this is going to be an easier ratio to set up if I think about what she paid rather than what she saved. You can do it with what she saved too, but this is going to save me a step. So now I'm kind of thinking, okay, I want to know 90% is that. So 90%, I don't need that in my ratio. 90 out of 100 is equal to, it's going to be part out of the whole. And since she saved, it was a discount, she paid the part. She didn't pay the whole price, she paid part of the price. So we know $23.25 is the part. We would like to know the whole price, P. So I hope that makes sense as just to how I set it up and how I think about it. A lot of percent problems, you just have to really do a lot of thinking. The math's not so bad, but the setup and the thinking and the common sense can be. So now that I've got it set up, I want to go from here to here. So I want to go from here to here. So 90 times what is 23.25? 23.25 divided by 90. So I'm going to multiply by about a fourth, a little more than a fourth. 2583 repeating. So I also want to multiply this by 2583 repeating. So I like to just keep that number in my calculator and then times 100. And so the original price of the gas would have been $25.83. This would be a good time to do a common sense check and kind of say, okay, would it 10%? That's a little bit off. It's not much. 10% of $20 is about $2 if I round. And so I should save about $2. And to go from 25 to 23, I did save about $2. So that kind of makes common sense, and we can say, okay. So guys, I think these are tough problems, and the problems that are coming up the next few days are really tough. So I need you to make sure you really have a good command and a good understanding of this. Not only how to do the math, but how to understand the problem. Is it a percent problem? Or is it a percent increase decrease problem? If it's a percent problem, what do I do with it? If it's a percent increase decrease problem, what do I do with it? So I would definitely recommend today not only going back and seeing these examples again, but check the I do and the we do and see if you can do it without me. Lots of times, certain kinds of problems are easy when I do them, and they're easy to understand when I do them, but that doesn't necessarily mean you could do them. And I think today and the next few mini lessons, they're very tough with percents, maybe those. So I would recommend going back, trying these again, and then seeing if you got them after I do them. So please do that. Please come to class fully ready, and I'll see you tomorrow.